A charged particle of mass m and charge q is moving under the influence of uniform electric field E and a uniform magnetic field B along y direction, following a trajectory from P to Q as shown in the figure. The velocities at P and Q are respectively v along x direction and minus 2v along y direction. Then which of the following statements A, B, C, D are correct? Trajectory shown is schematic and not to scale. Okay. So these are the 4 statements given to us and we have to find the correct one out of these. Okay, so first let's consider the first statement. Now let net work done by magnetic field be WB and net work done by electric field be WE. Now by work energy theorem we have WB plus WE is equal to half mv square, which in this case is 2v, minus half mv square. Now substituting the value of WB and WE, we get E naught is equal to 3 mv square by 4 qa. So statement A is correct. Now considering statement B. Now we know that rate of work done at P is equal to power of electric force, which is equal to Q E naught V, which is equal to 3 mv square by 4L. So statement B is also correct. Now considering statement C. At Q, electric field is perpendicular to velocity and already magnetic field is perpendicular to velocity. So dW by dt is equal to 0 for both forces, as dW by dt has this formula, right? So statement C is also correct. Now considering statement D. Angular momentum should be defined about a point which is not given in the question. But let's find angular momentum about origin. Alright. Change in magnitude of angular momentum of a particle at P and Q about origin is given as this, which when simplified gives us this result. The change in momentum is equal to 3 mva. So statement D is wrong. So the correct statements are A, B and C.